Hi guys, welcome to our channel Helm of Science. I am Shodan and I will be discussing the chapter Force and Pressure with you guys. So in my previous lesson I had told you about the various concepts of force, and today in this video I will be mainly focusing about pressure. So what do you mean by pressure? Now in my last video I had told you guys that a force can simply be described as a push or a pull. So suppose I push my hand with this marker. So I'm pushing it with the marker. So I'm applying a force, and I am applying this force on an unit area. So this area is nothing but the point of area of contact between the marker and my hand. So this is the area of the lid of the marker is the area of contact. So simply the pressure can be described as a force acting on an unit area. So it can be described as the force acting on an unit area. So in mathematical terms it can be described as force per unit area or force divided by area. So we know the SI unit of force is Newton as described in the first video, and we know the SI unit of area is meter square. So the SI unit becomes Newton per meter square, or simply it can be written as PA, which is Pascal. So the SI unit of pressure is Pascal or Newton per meter square. So now we'll move on to the various applications of pressure. First, pressure equals to force by area. Now if the force remains constant, if force is constant, if we increase the area, or we are actually increasing the denominator, so what will happen? The pressure will, if we increase the denominator, the pressure will decrease. So if area is increased, pressure will automatically decrease. Again, if area is decreased, so the denominator gets decreased, so the pressure will automatically be increased. So this theory is very important while discussing the applications of force, applications of pressure. The first application is that nails are made sharp. The pointy end, the nails have a pointy end. This is because the area becomes very less. Nails have pointy ends. First application is nails have pointy ends. This is because the area becomes much less, so we will have to apply much less force to apply a bigger pressure. So if the nails have blunt ends, so the area will be much more and we have to apply more force to apply the same pressure. So first application is nails have pointy ends. Knives have sharp edges. This is also same. We know pressure equals to force per unit area. So if they have sharp edges, so the area will be much less, and so we have to apply less force. Now we know the straps or handles of our bags are made broader. This is because if we make the straps or the handles broad, like the area will be much more, and so the pressure applied on our hands or our shoulders will be much less, so these are made broader. And another application of pressure is that the trucks which are used to carry more weight, which are used to carry load, are provided with much more wheels. This is because the area of contact between the road and the wheels increases, so less pressure will be applied on the roads. So now these are more or less few of the applications of pressure. So we will move on to a few numericals to understand this concept better. So numerical 1 says that numerical 1 says that a box weighing 100 newtons has an area of contact of 2 meters square. Find the pressure applied. So first we will write down the parameters which are given. So a box weighing 100 newtons, which is equal to the force applied by it. So force is given as 100 newtons. The area of contact is given as 2 meters. So area is 2 meters square. 2 meters square. Find the pressure applied. So from the formula we know that pressure equals to force upon area. Force is given as 100 newtons. Area is 2 meters square, so Newton, and this is meter square, so if we cancel it we get 50. So pressure equals to 50 Newton per meter square, or simply we can write it as 50 pascals. So this is your answer, 50 pascals. So the next numerical, we'll move on to the next numerical. It says that a box weighing, let's say, a wooden plate weighing 100 newtons applies a pressure of 50 pascals. Let's say 10 pascals. Applies a pressure of 10 pascals. Find the area of contact. Find the area of contact. So given the force is given, the wooden plate weighing, so it applies a force of 100 Newton, and the pressure applied is 10 pascals, or we can say it as 10 Newton per meter square. So from the formula we know Pascal, pressure equals to force per unit area. So pressure is given as 10, force is given as 100, and area we have to find out. So area is not given, so area equals to 100 by 10, and 100 is Newton, and the unit of uh, pressure is Newton per meter square. So Newton gets cancelled, it becomes 10 meters square. Area becomes 10 meters square. So this is your answer. So the next topic we'll be discussing about is the pressure applied by liquids and gases. So if we take a bottle, let's say this is a bottle, and I've with water. It's filled with water, and I've made a hole over here. I've made a hole and I've placed a balloon over here. So what we will see is that the water will fill up the balloon and it will inflate the balloon. So from this experiment we can tell that water or liquid exerts pressure on the walls of the container. Now similarly, if we take another bottle, another liquid filled bottle, it is filled with liquid, and we make holes. We are making holes over here. What we will see? We will see water oozing out from those holes, right? So we can say that liquid and the oozing out will be at the same speed, at the same height. So we will not see that from one hole the water is trickling down and from other hole it is coming out with full speed. From all the holes it will be coming at the same speed. So what liquid exerts equal pressure at same depth. Now in case of gases, like if we inflate a balloon, we are actually pumping air into a balloon. So a point will come when the balloon will burst open. So we can say that gases also exert pressure on the walls of the container. One more example is that if we pump air into a football, it will burst open. If we keep on pumping air, a time will come when the bladder of the football will burst open. So now one topic related to the liquid pressure is Pascal's law. Pascal's law. This law states that if we apply pressure, if we apply pressure on an incompressible incompressible confined liquid, it gets the pressure gets distributed equally. The pressure gets distributed equally at in all directions. Gets distributed equally in all directions with undiminished magnitude. Right. So what does it mean? So if we take an example, like we are taking a long necked test tube. It is a long necked container. It has a long neck and we have made holes. We have made many holes. Now we have placed a piston, an airtight piston over here. This is the piston. It is airtight and we have filled it up with water. We have made holes over here. These are the holes, and we have filled it up with water and placed a piston. So if we press the piston down, if we press it down, so what will happen? It will exert a pressure, and it will exert, the liquid consequently will exert pressure on the walls of the container, so it will cause the liquids to pour out of those holes, and it will come out of these holes with the same speed. From all the holes, the liquids will be coming out with the same speed. We will not see that from one hole it will come in a diminished speed, and in another hole it will be coming out in greater speed. It will all be coming out in the same speed. So this is the Pascal's law, and it's very important for your exams. It is often asked to describe the Pascal's law. Now moving on, we'll come to the properties of liquid pressure. We have already discussed a few properties, like liquid exerts pressure on the walls of the container. Liquid exerts equal pressure at the same depth. Liquid pressure increases with the density of the liquid, and the liquid pressure increases with the height of the water column, of the liquid column. I should say the height of the liquid column. So if there is a test tube, if the height is more, the height of water the liquid in the test tube is more, the more will be the liquid pressure on the test tube. So the next topic we'll be discussing about is atmospheric pressure. Atmospheric pressure. Now, what is the atmosphere? Atmosphere is the envelope of air around us. So atmosphere is the envelope of air around us. Now, what do you mean by atmospheric pressure? So the pressure exerted by the atmosphere around us is known as the atmospheric pressure. So I mean that the atmosphere exerts pressure on each and every one of us. So we can say that if the atmosphere exerts pressure on us, so why are we not getting affected by it? One explanation about it is that the pressure exerted by the atmosphere on us gets equalized by the pressure which is there inside our body. So our inside pressure balances the atmospheric pressure. So if we consider this theory, we can easily tell why the mountaineers often bleed their nose. Now, one thing before that we should know is that atmospheric pressure is maximum at the sea level. So the atmospheric pressure is maximum at the sea level, and atmospheric pressure decreases with increasing altitude. So the mountaineers the atmospheric pressure decreases with increasing altitude. So at high altitude, the atmospheric pressure is much less, and mountaineers get their nose bleeded. This is because the atmospheric pressure is much less and the pressure inside us is much more, which causes their nose to bleed. It is also the reason why astronauts have specially designed, specially engineered suits which they wear to outer space, because they have no atmospheric pressure in outer space, and so to balance that pressure they have special designed suits. So these are the few applications of. So now we'll move on to an instrument which is used to measure atmospheric pressure. So the name of the instrument is a simple barometer, or it is often referred to as a Torricelli barometer after the name of the scientist, which is Torricelli, who discovered it. So it consists of a test tube which is inverted and is placed inside a beaker. The test tube is marked and it is 100 centimeters long. It is 100 centimeter long, and it is kept inside a beaker containing mercury. It is kept inside a beaker containing mercury, Hg. Now the atmospheric pressure will be acting downwards. The procedure to set up this instrument is that firstly the test tube is filled completely with mercury, and by keeping a thumb on the open end we have to place it carefully inside the beaker. It was firstly completely filled. As it was inverted and it was kept inside the beaker, it will cause some of the mercury to come out of the test tube and fill up in the beaker. So firstly, which was initially fully filled, it will come down. The level of mercury inside the test tube will come down. This is also mercury and will be filled inside the beaker. So this level, this is the vacuum which it creates due to the inversion of the test tube. Now this the level which is here, the level of unfilled mercury gives us the atmospheric pressure, and it is often seen that at sea level the markings on the test tube is given as 24 centimeters. It is seen that at sea level the level of mercury inside the test tube comes down to 24 centimeters. So it is often seen that at sea level we can often say that at sea level atmospheric pressure can be expressed in terms of 760 or 76 or 760 mm of Hg. So at sea level it comes down by 24 centimeters. So 76 centimeters of mercury still remains in the test tube, and it can be expressed in terms of 760 mm of mercury. So these were more or less some of the major topics of the chapter force and pressure. So if you find the video useful, so please like the video and share it among your friends, and please subscribe our channel.